This is the definition here. A reference angle of theta in standard position is the acute angle, we're going to call that theta prime, formed by the terminal ray of theta and the x-axis. So a reference angle is an acute angle made from the terminal ray of the angle and the x-axis. So notice I have 3 graphs up here. We're not going to draw an example in quadrant 1, because in quadrant 1, all the angles are already acute, right? It's already in reference. What's a reference angle of 60 degrees? It's 60 degrees. But for all the other quadrants, we can draw an angle. So let's just draw an angle in quadrant 2. I don't care where. Somewhere in quadrant 2. Draw an angle. The reference angle is the angle formed by the terminal ray and the x-axis. If you can see that that's always going to be an acute angle in quadrant 2. Like, it would just be from here down to the x-axis, and we can call that theta. How could you figure out what theta prime is for if you know what theta is? Theta plus theta prime is always going to add up to be supplementary, whether it's 180 degrees or whether it's pi radians. So if we're solving for theta prime, I say theta prime equals 180 degrees minus theta. Or in radians, we could say that's pi. I don't really need to memorize that. You should be able to look at that in class. Quadrant 3 is probably the one that people get confused on the most with the reference angle. So, step 1, let's draw a quadrant 3. And again, it doesn't matter where quadrant 3 is. So theta prime is formed from the terminal ray to the x-axis. So in quadrant 3, what a lot of people want to do is just like over here where we connected, they want to say theta prime is from here to the y-axis. That's not true. Like, it always has to be formed with the x-axis. So there's 2 ways to do it. I always think positively. So I always kind of draw it in, well, I don't know. I tend to draw my arrow like this. That would be a negative angle. So you could draw it in like from the x-axis to here, whatever that gap happens to be, from the x-axis to your ray, I'm going to call that theta. And again, that's always going to be an acute angle when you're in quadrant 3. How could I figure out what theta prime equals in this one? Agree with that? And you can always think about an actual angle. Like, think of an angle in quadrant 3, 200 degrees. If it was 200 degrees, what would theta prime be? Well, it would just be how much more than 180 is theta. So that would make it 20 degrees. That's exactly right. Or in radians, you could say theta minus. And again, I really want us to get an habit of, if they give us something in radians, we're working in radians. If they give us degrees, we're working in degrees. So we're not switching between 2 degrees every time. And the last option is, what if we're in quadrant 4? Theta prime is from that terminal ray to the x-axis. So now we're just going to complete this circle, right? So this is just going to be theta prime. So how could I find what theta prime equals? right? Since the whole thing is 360, and we're just going to subtract out everything but theta prime. So if this was 330 degrees, it would be less than 30 degrees. Or that's the same as 2 pi minus theta. So part of what we're going to do today is we're just going to practice finding reference angles and drawing reference angles. And then we're going to be like, what's the point of this? The point is then we can take our special angles that we drew out on Friday, every multiple of 30 degrees, 60 degrees, or 45 degrees, and we can find the reference angle, and we can use that to evaluate them without a calculator, which means what was on our quiz, where you could only, your only possible answers without the calculator were 30 degrees, 60 degrees, or 45 degrees. You can extend that all the way around the circle. So, step 1, find the reference angle, and then sketch theta as theta prime. I think sketching is easier to do first. Sketch it, and then that helps you figure out where to find it. And again, some lenience there on the sketching, but you got to be somewhat accurate. So I did 1 in degrees and 1 in radians here. Probably degrees just over something like. What quadrant is 390? Or, so remember that this is 270 degrees. So don't just make a random line in quadrant 4. Kind of think about where that would be. So if we thought about counting by 30s here, right? So 270, 30 more degrees, that would be 300, and then 330, and then 360. So 300 degrees would be roughly like right there. I'm going to go just a little bit, like not halfway up that. And again, leniency allowed there, but you really shouldn't be more than halfway through there. You should be able to know that 315, right, is halfway in between there. And then we want to label which way we're going, right? So 309 degrees, I'm going to say from here to here is here. Or you could put from here to here, 309 degrees if you want to, like, put some value there. Which means it's really easy to label theta prime. We know theta prime is just from here to here. Just theta prime. I want to know what is theta prime, or how can I find theta prime. Anybody? Yeah, so we can take 360 degrees minus 309 degrees, which means we get what? 51 degrees. One degrees is not a special angle in our triangles, which means that doesn't really help us. We're just kind of practicing doing it. So on Friday, we made those 2 circles on the beginning of the notes of kind of breaking our circle up into increments of 30, 60, and 45 degrees. So I hope that we're starting to get there. We're practicing, and when we see 3 pi fourths, like, oh yeah, that's one of the special angles that I know where that is. Or if you don't know where it is, that you can think through without having to change degrees to do this. Because this is pi. So you can think about breaking that up into 4 parts, right? Fourths are right in the middle. So this is pi fourths, pi halves. So that would be 3/4 pi. So it's halfway in quadrant 2. Again, makes the reference angle easy to mark, right? Like you can just say from here to here, that's theta prime. And what would theta prime equal? How can I find theta prime? Which is left from here to here. Is that first? 1 whole pi? Because if you took pi minus 3 pi fourths, you would get pi. don't draw this, what I'm going to draw next, but I just want to show you where this is leading us. Alright, we're going to draw on the next page, so you don't have to draw it now. Why are reference angles important? One, when we get to the unit circle, this is where the unit circle comes into play. Like, this is how we get the values from the unit circle. But you can also always use triangles to evaluate it, because now that we know this is pi force is 45 degrees, which means, think about it, if you drew down the side there, do you see how that makes a right triangle? It's not just any right triangle, it's one of our special right triangles. It's a 45, 45, 90 triangle, which means that we could find the trig value at 3 pi force using the 1:1 radical 2 ratio to do that. And we're going to take that idea and extend it to the unit circle eventually. But that's why reference angles are important, because we get this little idea called a reference triangle that we can use to evaluate. So that's the other thing we were doing. So this is kind of my little steps that you need to do. Evaluating trig functions of any angle without a calculator. So step one is figure out what your reference angle is. And without a calculator, your reference angle is going to either be 30 degrees, 60 degrees, 45 degrees, or in radians, pi 6, pi thirds, pi fourths. Right? Without a calculator, that's what it has to be as your reference angle. Those are the only ones we can do without a calculator. So then I said, step one, find your reference angle. Step two is fix appropriate signs. And so that's what we talked about on Friday. Like in quadrant 2, the x is negative. Quadrant 3, both x and y are negative. And so we're going to do one of those. And then we can evaluate it using our special signs. So this is why on Friday we drew those out, because I want you to be able to tell me where 5 pi thirds is, or be able to at least think through where 5 pi thirds is, without having to take forever to do that every time. So, let's draw it. So if you remember the thirds and sixths that we drew, right, we talked about we can start at pi 6, and you can just count by 6 all the way around. So you can always do that to figure out where 5 pi thirds is, which is the same as 10 pi 6. Also, I kind of talked to you about where the thirds always were, if you can remember that. Or you could also just think about how big is this? Is it close to 2 pi, or is it not close to 2 pi, and figure out what quadrant you're in as well. So for me, I think about 5 pi thirds is almost 2 pi. Do you agree with that? 6 pi thirds. 6 over 3 is 2 pi. So that just means it's 1/3 away from 2 pi, which tells me it's in quadrant 4. Maybe you can just count all the way around. This is 9 pi 6. So you can know 10 pi 6 is down here in quadrant 4. If you have no clue what I'm talking about right now of how to get 5 pi thirds, you've got to be practicing that. You've got to be looking at that circle, those ways we drew it, and making sure that you can find that value without a calculator. If you're converting to degrees, you're going to have to make sure you can do that quickly without a calculator. This is all without a calculator. So I'm going to just say like that. This would be so my theta prime is going to be, I kind of already said it, what would theta prime be here? What's my reference? Pi thirds. Pi thirds is 60 degrees, right? I'm going to write that as pi thirds. Which means what we can make is we can make a 30, 60, 90 triangle in the fourth quadrant. And so what I'm going to do is I'm going to draw, and I'm going to make it dotted, you don't really have to, but I can kind of extend that terminal ray down, and I can do right triangle trig in quadrant 4. But what we have to know is we have to know what's labeled beside. So 60 degrees, right? 30, 60, 90 triangle. Remember the ratios are 1, 2, square root of 3. The biggest one is hypotenuse. So that means 2 is my hypotenuse. 1 is my 30 degree one, right? So this is 60 degrees. That means 30 degrees. And that means this is the square root of 3. But here's where my little step 2 is. In quadrant 4, do you agree that like this would be negative square root of 3? How does this relate to what we did Friday? Think about what the point would be down here, right? The point, the ordered pair that would make that triangle would be the ordered pair 1, negative square root. And so that's where I get my sine. I don't ever really use it. So if you know that, I now can say the cosine of 5 pi thirds is the same as using that reference angle. So cosine is adjacent over hypotenuse, or x over r, which means that I can say x1. A lot of side work to get to my answer. This is why it would be without a calculator. So if I'm without a calculator, you don't have a lot of work to show. Questions on where I am at here? I could ask you to find the sine of 5 pi thirds, and the sine would be negative square root of 3 over 2, right? Because it would be opposite over. So pay attention to your signs on that. All right, what if I gave you something like number 4, the tangent of negative 240 degrees? Do you want to draw a negative angle? Could we draw a negative angle? How do we draw a negative angle? Tyler, how do we draw negative angles? Clockwise, right? Isn't counterclockwise what we normally do? Yes, but you knew what we meant. So if we started here and went backwards, this would be like negative 90, this would be negative 180, and we could draw a negative angle in. I'm not a big fan of negative angles. I don't like thinking that way. Can I make this a positive angle? On the quiz, I asked you find a coterminal angle, one positive and one negative. How do you find coterminal angles? You add 360. So one option is we could make the negative angle. I promise it also works. Use your reference angles. Another option is if you don't want to make a negative angle, find where that is as a positive angle, which means I can just add 360 to this, and it's the exact same angle. And so then I can work with positive angles instead of negative angles. And that just makes it the tangent of 120 degrees. Do you agree with that? So, that's the great thing about coterminal angle, is that you can make every negative angle into a positive. And then you can graph the positive angle, and probably 120, you know this is 90, so 120 is going to be right over there. Which would also be the same place as if we did negative 240, we would have ended that way, and the arrow would have just been going the other way. The big idea today is find the reference angle and make the special triangle. So if this is 120, what happens to be my reference angle again? Degrees, which happens to be the same thing that was over here. You got 3 choices right now for reference angles anyway, so it's going to be 30, 60, or 45. Which means 60 degrees, I can draw down my triangle. Look, I've already abandoned the dotted line. And if this is 60 degrees, the side opposite 60 degrees is the square root of 3. The hypotenuse is still 2. The adjacent, now that I'm over here on this side of the x-axis, this is where you got to pay attention. The adjacent is negative 1, right? Not positive 1. And if you can draw your triangle in, now you're just going to do the tangent of that. The tangent of 120, or the tangent of negative 240, is exactly the same as the tangent of this triangle that we drew in. It's called a reference triangle. So opposite over adjacent would be square root of 3 over negative 1. And we're not going to leave our answer like that, right? We're going to simplify that and say that that's just negative square root of. That's a lot of homework today is doing stuff like that. So then what about if they gave you something like this? It says, given that the tangent is negative 15 over 8, and that the sine of that angle is less than 0, find the 6, maybe gave us 1, so they were 5, that's fine. First of all, step 1, negative 15 over 8, is that using my special angles? My special triangles? No, that's not. Okay, that's square root 3, so square root 2 in there. So this means it's going back to the stuff that we did on Friday, the point. Or the SOHCAHTOA stuff that we know. What's the ratio for tangent? Opposite over adjacent. Or when we learned on Friday with our x's and y's, you remember what it is with x's and y's? Y over x. Right? So it's like they're giving me that ordered pair. But it's kind of tricky because do you know which one's negative? Because it could be the x is negative or it could be the y is negative, right? Like you don't, just like on our last one, square root of 3 over negative 1, you just wrote that as negative square root of 3 without really knowing. So in every question like this, they always tell you two things. Because if they didn't include this part, tangent can be negative in 2 quadrants, right? Tangent can be negative in which 2 quadrants? It could be negative in 2, or it could be negative in 4, because those are when the x and the y have different signs. So this is why they have to tell us this. If they tell us sine is less than 0, what are they telling us is negative, the x or the y? The y. We did on Friday, we learned that sine is y over r. Right? So we have to kind of make that transition from SOHCAHTOA to knowing the relationship with x's and y's. So if they're telling me that sine is less than 0, they're telling me that y is the negative one. So it's exactly as it looks, that y is negative 16 and x is 8. Which means I know I'm in quadrant 4, and if I wanted to draw a picture over here, I could roughly say, like I'm not going to be accurate, I'm just going to say this is negative 15 and x is 8. Which means I could make that points down there, and I could draw the triangle just like we just did, only now it's not using the 30, 60, 90. Now we're saying this is negative 15, this is 8, and then we can solve for the hypotenuse here. So we know that r equals the square root of 8 squared plus negative 15 squared. That equals the square root of 289, which I think is a perfect square. 17. So we did questions like this already, but we didn't do them outside of quadrant 1. So now that we're anywhere in the circle, they have to give you that second piece of information that you know what quadrant it is, so that you can only decide their both x and y. And if you can draw that picture, or if you can find x, y, and r, just like we've been doing, then you can just list all the other trig functions, or until we go out here to count. If they gave me tangent, the easiest one to do would be cotangent, because I can just flip it over and say, we're talking about it, we're just that, kind of reiterating some important things. You have to put something next to tangent, cotangent, and you have to put theta for the angle that you're finding. Like you can't just say tangent equals tangent of what. So usually it's theta. So sine would be about negative 15 over 17, and cosine would be 8 over 17. So a point of knowing, am I talking about my special triangles or am I not talking about my special triangles? And you guys have looked at those questions and know that 15 over 8 is not a ratio of my special triangles. So that's how you know you're not using simple triangles to do that. Okay. Questions about that? I was just thinking as we did this, I thought someone might have a question over the homework on Friday on the ones that, like 9 and 12, when they gave you a point that was on the x or the y axis. You can't really draw a triangle when you're on the x or y axis, but you can still evaluate them using our y over r, x over r to do that. So, that kind of applies to this problem. It says, tangent of theta is undefined, and they tell us that theta is between pi and 2 pi. So, step 1, if theta is in between pi and 2 pi, what two quadrants are it? This is pi, this is 2 pi. So I'm 3 and 4, right? No, that was not. I was agreeing. I was just drawing a picture. Pi to 2 pi. Which means I'm somewhere in here. What's the ratio for tangent in the coordinate plane? So not opposite over adjacent. Y over x. So if they're telling me that tangent is undefined, what do I know? I know that x is equal to 0, because that's the only way we're going to get an undefined answer. So again, all of the stuff that we've been spending so much time on, that I'm not rushing through, is because this is like the foundation of trigonometry, of knowing these values. So you have to tell me, between pi and 2 pi, where's the only place that the x-coordinate is 0? It's here, right? And really, you could think about it as, if you wanted to write it as any value, you could write that as x is 0 and y is anything. Because if you solve for r, right, if y was any number, just kind of show you where this comes from, and then we can change it to actual numbers if you want. If we solve for r, knowing that r equals the square root of x squared plus y squared, do you agree that r is just going to equal y? Always. And I hope that you found that on 9 and 12, when they actually gave you a point like 0, 5, or 5, 0. If one of the coordinates is 0, when you solve for r, it's this. If y is 0, then r is x. If x is 0, then r is y. Which means that you don't even have to know what y is. You could just call it 0y, or 0 any number, and it would work out that you could find all the values here. Because the ratio for sine is, oh, I guess I'm a little off here. This should really say 0 negative y. Do you agree with that? Because I'm down here in quadrant, and the y-axis is gone. Which means when I do the sine of this, the sine would be negative y over y, because r equals y, which is why we get negative 1. So we're like so close to this idea of the unit circle. The reason that the unit circle works is that it works no matter what y is. So we just picked 1 because 1 works out really nice. If you have a radius of 1, that's amazing, right? So if you call this 0, negative 1, it's the same as 0 any number, and so that's why we say at 3 pi halves, we're just going to call it the point 0, negative 1. And the cosine, it doesn't matter where we are, because the cosine is x over r, and x is always 0. So that means that the cosine is 0. And they already gave us tangent is undefined. And then we can just switch them around, right? So if the tangent is undefined, what does that mean for the cotangent of theta? It's just 0, because now 0 is on the top. It doesn't matter what y is. And the same thing for cosecant. It doesn't matter what y value we're at. If we flip that over, negative y over y, if you flip it over, it's still just negative 1. And the secant, if we flip 0 over, we're now undefined. And you should have found that on 9 and 12 when you did those. Well, not 12. On 9, I guess. 9 was the point 0.05, which means it was up here. And the x was 0, which means you're going to have undefined. And r should have been 5, which means that 5 over 5 gives you a sign value of 1. And so as we get close to this value, this idea of being a circle, sometimes people struggle. What if you were outside the circle? The ratio still applies at any of values, because the ratio is still the same when you do that. All right. So again, kind of some thinking involved there as we do this. This will be a no calculator question. I was just talking about the previous homework. Number 9 from the homework. So day 2, 21 through 48, but I said skip 39 and 42. So that really would be like 21 through 36, right? And then 45 and 48, if you want to write it out like that. And we'll hit 39 and 42 tomorrow. I believe on your homework sheet you only have 3 days of this, but I break up day 3 into day 3 and day 4 with idea of the circle. I think you should be doing most of this without a calculator today. 21 and 24 are trying to make you think, like, what would the ordered pair be on a reference triangle? Definitely through 36. You should be able to find your reference equals. You might have to add or subtract 2 pi, because you might be bigger than 2 pi or smaller than 2 pi, like our one that we did. And then 45 and 48 are like our last one. You definitely shouldn't be typing 6 functions in your calculator if you're trying to calculate yourself.